Okay, we're going to do some distillation and reflux today. I'm going to show you the practical procedure and talk you through some of the theory of how and why we do it. So, distillation and reflux are two separate techniques which you will need to know for your A-level PAG. Now, this is a reaction we're going to do. We've got propan-1-ol I'm going to put into a reaction with an oxidizing agent. Now, the oxidizing agent we represent with an O in square brackets. And in this case, what we're going to use is acidified potassium dichromate, which is K2Cr2O7 with acid. You might also see this written as Cr2O7 2 minus H plus. So this is a dichromate ion and it's orange. The idea behind this is that the oxidizing agent is going to oxidize the propan-1-ol into the propanal, and when it does this, it will itself be reduced. So we're going to start off with chromium ions there, which if you work out their oxidation state, they will be 6 plus, and what we're going to change them into is Cr3 plus. The Cr6 plus is orange and the Cr3 plus is green, so we're going to see an orange to green colour change. Now, the way we're going to do this is we're going to distill off the propanal as we make it. So the propan-1-ol, we don't want any of that in our product. We do want lots of propanal, and so therefore we need a way to separate it. And the thing that's really useful about this is that propan-1-ol and any alcohol and aldehyde pair work a little bit like this, but propan-1-ol happens to have a boiling point of 97 degrees C, and propanal only has a boiling point of 48.8 degrees C. So what we're going to do is we're going to make this into this, and as we do, if we keep the temperature low enough, this one will stay in the reaction solution and this one will evaporate. What that means is if we set up a distillation apparatus here with our acidified potassium dichromate and our alcohol in here, we should be able to make our product evaporate up here and go down a condensing column. This is a condenser, and then the aldehyde will end up in here. Any unused alcohol will end up in here. So what we want to do is we want to take our distillation apparatus. We've got a round bottom flask here. We've got a still head, which is this three-piece thing here. That's clipped here and here. Now it's not clipped here because the clips tend to melt if you put one there. Thermometer here is really important. Okay, without the thermometer, okay, this is not going to go well. The bottom of the thermometer has to be right here by the still head, and we have a clip to this condenser. Now the water here just goes round the outside of the tube. It's not going in the tube, it's going round the outside, and the idea is that that's going to cool down anything which comes through here. Over this end I've got a delivery tube into a test tube, and we're going to collect our aldehyde there. So you can see in the bottom here we've got the anti-bumping granules. I'm going to add into that my acidified potassium dichromate, and into that we're also going to add my propan-1-ol. Okay. Now to cool things down here, I'm going to need to attach to the water tap, which I've already done in the background there. Now the one which is attached to the water tap is the one in the bottom, so that down here, so that the water can flow upwards, okay, and it will fill the entire condenser. So we'll just turn that on, and you will see in the condenser from the bottom water, and the idea is to try and get rid of all of the bubbles and just have water in the condenser. Okay, so the product will form in here, it will evaporate, everything's going to evaporate, but as long as the temperature here is not too far above 48.8 degrees, what will happen is most of what comes down this tube and condenses in there will be our product, and that will go into there. What's needed here is skill and dexterity, so I'm just going to take my Bunsen burner and heat it underneath. Okay, I'm going to look for it condensing on the sides. You see it's clouding up there, and then I'm just going to take it away for a minute. Okay, the Bunsen burner is just going to sit at the side, and then I'm going to reheat it. I'm going to do this gently. I'm watching the temperature at the top, which currently says about 23 degrees. I'm going to keep heating, but I want slowly that temperature to rise. So this is reading about 60-ish degrees. I don't know if you can see it on there, but that's okay, because our next most volatile product thing in there, apart from our product, is actually the alcohol itself, and that's 97. So as long as it's below 97, then I should be fine. Now down here we've got another change. You can see that that is now definitely not as orange as it was before. That's now gone a green colour. Okay, and that tells me that the reaction is working. At the bottom, that gradually, little bits of my product should be coming through. There's one. So the other thing we can make with propan-1-ol is propanoic acid, and all we have to do for that is react it with twice as much oxidizing agent, and that will make a carboxylic acid, propanoic acid. Again, we get the orange to green colour change, but this time, in order to do that, well, we need to stop the aldehyde evaporating, because if the aldehyde evaporates, it will kind of like change from propan-1-ol to the aldehyde, and then the aldehyde will evaporate and you'll never get your propanoic acid. So we need to keep the aldehyde, and in fact we need to keep the alcohol as well in there, and we need to heat it really strongly. So to do that, we heat it under reflux. We've got the anti-bumping granules in here. Okay, we're going to add our acidified potassium dichromate. We're going to add our propan-1-ol, and then we're going to attach the condenser straight to the top. There we go. So this time the propan-1-ol will heat up, it will evaporate first probably, it will get to here, you'll see it condense, and then it will fall down and drip down to the bottom. Any aldehyde which is made is going to go up, it's probably going to go a little further, but it will still condense on the side, and then it will drip back down into the reaction mixture. And this way we can make sure that as much propanoic acid as we can is made. None should come out at the top at all. We'll leave this here for a reasonable time to make sure that as much has reacted as possible. Relatively gentle heating. We don't want to go too hard. We're not monitoring a temperature this time. But remember, we only need to heat this up to about 100. So that'll be the, you can see the boiling of the propan-1-ol. And then everything else will start to boil in a minute. There we go. Now, can you see the fog at the top here? Okay, that is the evaporating substances condensing on the side and then dripping down. You can see there's a kind of like fog layer heading its way up the condenser. We do not want that to get to the top. If it gets to the top, it's too hot. Okay, so we're just going to leave that there until it comes down a little bit. Again, gentle heating, and this time you can really see that that's going greenish already. So we're rolling boil it. We're on a rolling boil now, and you can see it's dripping at the bottom there, dripping out of the condenser, and that is a reflux. And at the end we should have some propanoic acid.